Okay. So, hi everybody. I'm Alessandro from Team1, and my team is also formed by Pranjay, Ara, and Sonju. And today we are gonna present the midterm presentation of our project. So our project, the title is Analyzing Person's Routine to Predict Future Location, and particularly my routine. So here's the table of contents. So at the beginning, I'm going to do like a little recap of the project, so our goals and our aims. And then I'm going to explain what we did in this second part of the project, so the data acquisition and the data extraction. Then I'm going to make a little preview of the future works, so what we will do in the final presentation. And finally, job allocation and schedule, and show the reference we used for this presentation. So, project recap. Our goal is to predict the weekly routine of a person, and to do so, first we have to design an application that collects the GPS data from the smartphone, and then we have to decide which algorithm to use to do the machine learning, and thanks to the machine learning we will make our forecast of the position. And our additional goal is to visualize the results on a map, just to make it simpler to see. Okay. So here in these slides, you can see basically all the project, and the part that is highlighted is the scope of today, so what we did in this presentation. So we did the data acquisition, we acquired data, the GPS data with the smartphone, and then we extracted this data, and after that we will use the machine learning and do the prediction, and we will use the TensorFlow libraries to do the machine learning part, as I will explain later. So the data are gathered with the smartphone, extracted, and then pre-processed in order to be used for the machine learning. Too many arrows. Okay. So for the data acquisition, let's see more in details. We decided to use an app called GPS Logger. Basically, we look at since there are many apps already made for this purpose, it didn't make sense to design another one. So we just look at some, and we found this one we chose because it's basically really easy to use, and also has the advantage to produce data in different formats, which are those formats you can see here. And the app uses the GPS chipset of the phone to get the position of the user. And we decide to use the data in the GPX format. This basically because it's a format, an XML-based format made specifically for the GPS units, and so it gathers much more information compared to the other formats. Here you can see the screen view of the application. So you see here. Oh, do you see the mouse? No, you don't see the mouse. Okay. So on the top, there's the status. So if it's green, it means that the application is recording the data. Those big numbers are the coordinates, latitude and longitude, of the last point that the app gathered. And you can see this green little rectangle, which written like stop logging, means that now is working. At the beginning is like blue with written start recording. So now it's recording this picture. Then you can see the accuracy, which depends on the number of satellites, because this application works automatically. Automatically choose the satellites that are available. And finally, you can see the point log. So in that part, it shows how many points were recorded, like in this moment, how many points it has been recorded. Okay, so to do this project, we made some assumptions. So we took KAIST campus as area of interest. So we just take a restricted area, also because otherwise it's going to be too complicated to take so many really big area. And we decided to focus on a daily routine schedule from Monday to Thursday. This because basically, since we gain data of myself and I have class from Monday to Thursday, these are the 4 days in which I have a more strict routine. So it makes more sense to make a forecast in this period. And from 9 to 5, which is basically the time in which there are classes. We're getting the data position of latitude and longitude, and more or less per day we're going to have between 300 and 500 points. So now we are looking more in details on the data extraction. So after taking all the data in the GPX format, we have to use a GPS extractor for us. After getting all this information, we store this relevant information in a CSV file because it's easier to analyze for the machine learning. And then we will do the machine learning part and make the forecast and plot the coordinates on a map. Here you can see more in details the data extraction. So on the left, you can see that this is the GPX file, and you see that there are many data like latitude, longitude, but there's also elevation, for example, and the source, which are useless for our purpose. And on the right, you see the CSV file that we produce with just the data we need. So you see, we just need the latitude, longitude, and the timestamp of the position we took. And here, in the next slide, we just show an example, some example of data gathered. So here, from Monday to Thursday, this was the first week we analyzed. And you can see the dots, which are basically the points in which the app took the position of the user. And we just linked the dots with a line. And here the same for Tuesday. And in this case, we have an outlier. So because on that day I went to visit a power plant with another class. So see, the map is super big. So this is not gonna, it's like outlier we have to consider when we do the machine learning. And this is the last day. So after gathering the data and extract the data, we have to think about what to do in the next project. So to do the machine learning, there are many models available. And of course, every model has its own advantages and disadvantages. And since right now we don't know which one is the best model, our aim is to analyze all these models, and in the end we will see which one fits better the data or which ones fits better the data. And all these models are available in TensorFlow, so we can also use TensorFlow for this part of the project. Here there's the job allocation, so you can see in the line what we are now, and we are gonna keep collecting data until the last week available, and we divide between each other the algorithm, the model's analysis, and in the end we're gonna visualize the results, and we hope to show you some good results. So these are the reference, and that's our project. Thank you, and if you have some question. Yeah.
So you're trying to get the location specific time.
Yeah. So basically, we analyze many weeks, and then we want to say, let's see where the user will be on Monday at 10 a.m. And based on all the data we have and the machine learning, we will say he's going to be here on the map.
So when you do the training, are you setting the day and the time? Or just time, like 24 hours? Are you also setting one day,
Yeah. We're going to divide it in days and in the time period between 9 and 5. Because this is the time.
Depends on you whether you can just differentiate it by just the time of the day, or you can set it like a week, or you can also say there's a month step. What I'm saying is, if you differentiate into a level of months, then you should train for many months.
Yeah, of course.
You don't have that much time. So
Yeah, no, we can also do it for years and
you're
years.
cutting it as a week, right?
Yeah.
So you can, so you're kind of deciding using the also the information of the day, what day is it today, Monday or Tuesday.
Yeah, exactly.
My comment is that so now it is for now it is appropriate for the objective of this project, but you can also link it with the other kind of variable. For example, you cannot think of a good example. Maybe with some kind of like unrelated variable. Like maybe it seems unrelated, but you can find a relationship between the location and something, some other variable. For example, like what do you eat in the day? Or, maybe that is hard to quantify.
Yeah, also because I don't remember what I ate all these days. So.
How much you ate on that day?
You mean if you think about how many time I spend in the, I don't know, in the canteen? You mean that's what you mean? Like
Time and location is not that crazy.
Yeah.
Time and day is kind of first thing you can think of. Maybe link with other variables will be more crazy. This is the point. You don't
Okay.
have to do it.
Okay.
You have additional time. What was your additional goal?
The additional goal was to visualize on a map the forecast.
And you said you were testing various kinds of models, right?
Yeah. Yeah, here.
If you're doing k-means clustering, k-means clustering is something like getting a cluster in the data set, right? Finding so how you do the k-means clustering?
actually that is where the map helps us. Like if you can just show one of the samples.
If you stay
Yeah.
one place many times.
Exactly. So we have a lot of locations like these, right? So if you could see the concentration of the red dots. So that is actually where the K-means clustering would help.
And the result would be something like
A cluster, a set of clusters. Yeah.
you stay a lot of times.
Yeah.
So I expect to see all those results from all those methods.
Sure.
As I understand, the ultimate goal of this project is predict to realize the goal tomorrow for the next day, right?
Yes.
After using the training data set of this GPS data. Is it possible?
For the weekdays, yes, because that's when the most predictable schedule happens. Like most predictable schedule, like on the weekdays you are supposed to go to the lab or supposed to go to the cafeteria to eat, right?
Yeah.
On the weekends you are more flexible. Weekdays are fixed, like kind of fixed. Only the time is the variable. Like I have to report somewhere at 9, but I reach there at 9:39. Right? But on weekend I don't have such limitations or constraints. Weekend I'm free. Weekdays I have to do work. Yeah. So in that manner, weekdays are best to analyze the data.
And also I'm trying to walk always in the same path, like all the day, try all Monday to do the same road in order to have more or less similar data. Of course, there's some difference depending on the time. Sometimes I'm late, sometimes I spend more time in the canteen, but more or less I try to keep it closer.
So, I heard so the data of your visiting of Outlier?
Yeah, but this is an outlier. It's an outlier, so it's a data whose complete we know it's wrong. So
You know,
yeah, since I know what I'm doing, I know every time if I do something which is not in the schedule, like so I'm able to say this day there are some problems in this part of the day. So also when we analyze the data, we know where to look, where something is not as it's supposed to be.
page 4. Basically, you choose one of model of machine learning model in principal library, right?
Yeah, the models I showed you before, we try to use all of them, and then we see which one is the one who fits better the data, who gives us best results.
You don't have any plan of using uses of the neural network.
Neural network type, it's like we can implement the machine learning models in a neural network, but that would be just a waste of time because neural networks are supposed to do much more complicated tasks, more like image or speech recognition. In the sense that neural networks are a kind of a deep layer stack by stack, right? So if we use it in these kind of models, we can use it and we'll get the result. But it's like it would be an additional task in the sense that machine learning models can do that work. Using neural networks is just like showing that you can do the same task by a different method. The results are not going to be much more like there won't be any change in the results because of the task which we have in the hand. Since we only have the data points, right? We have the GPS coordinates, only, and the timestamp. So these are the points which are not, which are like only 305 minutes to 5 minutes data points. Neural networks are supposed to be used when you have much more complicated tasks. Like if and take an image, you have like thousands of data points just in a single image, and you have to like figure out the relationship.
I understand. But as in my opinion, actually there are good results could predict where I go to more complex machine learning model vision and using data set of GPS additionally or something like schedule data.
It's more like, yeah, I'm also working on neural networks, so it's like neural networks I prefer to use only when we have a lot of complicated set of data.
But you mean that just using the relations
Yeah.
this is one of the examples of statistical data.
Yeah.
Yeah.
Mm-hmm. Yeah.
So to train the complex data, it's used to
It's like, no, it's more like you don't need that high level of sophisticated algorithms for these kind of applications. It's more like when you have a video, right, a stream of images, then you need these kind of applications and algorithms.
The techniques that we showed in the slide, those techniques are also the basics of the machine learning regressions or the regressions. And as Pandey said, we don't think we will require to test or use neural network for this specific task because of the complexity of the project. It's not that complex, but if we go after we go through all the regression, then we don't have any satisfactory result, then we may try neural network.
So I agree with you that those are basics of machine learning. But for using those kind of methods, TensorFlow is not necessary. So are you still using TensorFlow?
Yeah. It's not determined, but
TensorFlow is actually also, it also has the libraries for machine learning algorithms as well as the neural networks. These are available in TensorFlow.
I'll provide
Yeah.
to reduce the effort to implement. Using TensorFlow will be easier.
But there are many others.
Libraries?
Yeah, like
Yeah, but
R
the thing is the support of the libraries. Like TensorFlow is maintained by Google, right? So like I kind of trust that. So it's like because there are other libraries as you mentioned, but the source of the programmers are not.
So you said those are sufficient for this kind of application.
Yeah.
I agree with you. That aspect, but terms of usefulness of this application, like, do you think this can be very useful for the user?
Not this, but an extended version of this. Like, if you could recall that in the beginning we mentioned about the surveillance systems.
What system?
Surveillance systems, like if I have a tracker with the same model on a bigger scale, I can track a person and like predict where he would be. Like here the assumptions that we would be restricting to just KAIST class. Yeah, and it's scale.
It's for someone who cannot find the same variable or fit, right?
Yeah, that's it.
So normal people.
Also, maybe if you lose, I don't know, the keys of your house, you see, where should I be? Just look where you have been. I don't know. You think I think I lost it 1 hour ago, and I said 1 hour ago I was here, and I tried to look here. Huh?
It's just a record.
But
In these days, like like the Siri of the iPhone or any kind of AI in the smartphone, it provides you like where should you go or like something like that. So maybe this kind of app can provide you what you should prepare or what you should carry with you when you're going out from your home or something like that. So
yeah.
you can maybe provide more useful information rather than just predicting the location.
Yeah, it's more like
Yes.
the more we discuss, the end users would be increased.
Yeah.
Yeah.
You spend more, I think it will much better. That is my point. Thank you.
Alright. The problem is fitting my expectation and using big data and neural network is used for some kind of prediction. Fitting my expectation. The problem is too simple as not related. So next step, I hope we can increase the complexity of prediction function. Not only prediction, it can increase more. By increasing the complexity and prediction, we may need more data. I don't know.
Yeah, we try to keep it simple also because we wanted to at least fulfill one goal. Let's say, okay, we want to reach this goal, so if you do something too complicated, then maybe you cannot not able to reach the goal, and we want to be sure at least to reach one goal. Since you said we have to do that.
It's my recommendation. Because, see, the problem is that the Team2 problem is more complicated. Prediction of patients' failures. Yeah, it's a complicated problem. So by comparing the only prediction, your one is very simple. Then Team2. It's just a recommendation.
Okay.
And one more comment is I want to see more explanation on your big data. Something like how big is it? How many days you record?
Okay.
Months or week? And who is the target person?
Me?
I want to see more details on your big data.
Okay.
Alright, thank you. And one more thing is you can revise